Please pause the video and take a moment to read this important safety message.
Hey, welcome back everybody. Part 4 here in this tube gear troubleshooting series. Hoping to keep making this series, having a lot of fun with it, and I've got a lot more tube gear in there we could use as examples in this series. So hopefully we're all learning something here as we move forward. Let's talk a little bit about the approach I'm going to take next in this video. It's about selecting components. Now we've figured out what was broken about this amp and which components was keeping it from working. Now we're wanting to talk about how would we go about doing kind of a full restoration from an electronics standpoint on this unit. And you know, I got some feedback on the last video, hey, just replace all these capacitors, do that before you bring it up. And I agree with some of what people were saying. I put some strain on one of these tubes because, you know, this capacitor here was leaky and we had 17 volts on the grid. Well, that's not good for the tube, but I did it in the spirit of teaching you guys something, and I always like to find the failing component. So I'm willing to take some risk, if that makes sense. At any rate, today the topic we're going to get into might be highly subjective. And the reason I say that is I'm going to walk you through how I would select components for this amplifier. Maybe very different components that I would select than one someone else would select. And a lot of that gets into flat out very subjective, you know, material, almost a religious type debate, kind of a Ford Chevy type thing. And the answer is probably my way is right and someone else's way is right, and neither are wrong. So having said that, let's dive on in to how we go about selecting components for this unit. So the first thing I like to do is pull out a handy dandy notebook, okay? And I've got one here, you can see. And what I've written down is Fisher A20 Mono EL84 amp. And I've got many of these notebooks like this, and I always label them with little stickers I put on them. But and if you flip back through this, it's notes I take on things. I refer back to these notebooks an awful lot. Because the next time I get an A20 in, guess what? I've already got a parts list laid out for me then at that point. And I hate the shadow from this thing is kind of getting in the way here. But what we're going to do is go through and just document, or if you want to use the word blueprint, this amplifier from an electronics component standpoint for the things that I feel we need to replace. So why don't we start out by listing out the capacitors that are in this unit and writing them down here on a piece of paper, right? So the first thing we've got is this big can cap right down in here, and if we flip the unit over on its side, it's right here. And if you read it, it says 40 microfarad at 450 volts, 40 microfarad at 450 volts, and 20 microfarads at 450 volts. In other words, there are 3 capacitors inside of this one unit right here. And as you can see here, I've written down, I've made a list of, I'm starting to make a list of capacitors, 40, 40, 40, 20 microfarad. They're all at 450 volts. And I went ahead and wrote down it's a can cap. One thing you might want to consider doing, depending upon the unit you're working on, you may want to measure the height of this unit and actually write that down as well. That way when you go to buy a replacement, you don't end up getting one this big and then the cage won't go back onto it. So you may want to do that. All right, let's jump to the next capacitor here, right? We've got this 0.02 microfarad capacitor, and by the way, this one here was also a 0.02 microfarad capacitor at some point in time. Someone has been inside this unit before and replaced this style capacitor with one of these. But I'm going to go ahead and replace both of them, even though this one tested good, just so that I have kind of matching capacitors on both sides. And what you will find is in today's times, now that we have IEC standards around capacitor values, 0.02 microfarads is not a common or standard off-the-shelf capacitor anymore these days. So we're going to go with 0.022 microfarad capacitors, and I promise you it won't make a world of difference at all in this unit. And if you kind of roll this capacitor over a little bit, you'll see it's at 400 working volts DC. So I know I need one of these, I know I need two, and I'm going to put down 0.22 microfarad, 400 volt coupling cap. We'll write that. Okay. All right, onward to the next one here. So we'll take that into account for this one and this one. Then we've got this cathode bypass capacitor here. And if you'll notice here on it, it'll say it is a 50 microfarad at 25 working volts, okay? Well, guess what? Same scenario here, right? I'm going to need one of those, and they don't make 50 microfarad capacitors anymore. I'm not saying you can't find one. I'm not saying you can't get a specialty made one. I'm just saying the standard value these days that you would buy would be a 47 microfarad capacitor, and that's what we're going to put in here, and you will not notice a difference. So we'll just write down 47 microfarad at, and this said 25 working volts, right? And this is a bypass cap, and it is an electrolytic. All right, so that gets those two. Then we've got a big capacitor right here, which is a 0.1 microfarad at 200 working volts, and that is a standard value these days, 0.1 microfarad at 400 volts, and we'll just call that a coupling cap. It's really... And what that is so that if you were feeding this with a piece of gear before this and it happens to have leaky output, it doesn't put 400 volts onto the input here, or however many volts, onto the input of your unit feeding in here. So it's kind of a coupling cap on the front end here. And then there is a 68 mmF, and it doesn't say that on the capacitor here, okay? You actually have to go over here to the schematic itself, and you'll find this little 68 mmF capacitor right here at 10%. If you'll notice, this is coming off the 16 ohm tap of the transformer, and what this is your feedback loop on this unit. And if you follow this little yellow wire right here coming off the 16 volt tap on the transformer, it feeds over and it goes right here to this place, and then that's where your feedback loop comes back in. So we've got 168 mmF, otherwise known as 68 nanofarad. You won't find mmF used anymore as nomenclature these days. You would find that as, this was 68 microfarads is what that was, which equates out to 68 nanofarads, and this is just a, we'll just call this a coupling cap as well. Pretty much anything that's not an electrolytic I'll define here as a coupling cap of some type or another, even though it may not be serving that purpose. Then we got another one down here, and it is a 24, and this is on the heater wiring. We could replace that, we could not. And honestly, both of these are probably fine, but while we're in here, I'm going to go ahead and do it. So we got 24 mmF equals 24 nanofarads, and we'll list that one down, as you can see here. And then what do we have left capacitor wise? Oh yeah, we've got this nice little right down here, the death capacitor right on the front end, and I'm just going to write down 1 XY cap, because I'm not going to replace that with another coupling cap of any type or whatnot. I'm going to use a XY safety cap, okay? All right, and so that gets us all of our capacitors laid out here on our little list. Now we're starting to build a parts list here for this unit. All right, up next what we're going to map out, and I've labeled it here on my paper, are the resistors. And I just like to start kind of left and right and work my way over on the amp. There are no resistors down on this end whatsoever. First one we get to as we're coming along here is this orange-red capacitor right here. which would be our 3.3K. Okay, so we're going to need one 3.3K ohm resistor. And if you'll notice, this is a larger size resistor, carbon. It is a 1 watt resistor here. So it's always important to capture down as you're making your list for resistors, is the size. Okay, up next we're going to kind of move this way here. What do we have? Let's look at what's beside this 68 ohm here. We've got a brown, green, orange with silver on this. That is a 15K ohm resistor. Okay, so one 15K ohm resistor, and these are all quarter watt resistors, but I'm going to replace them with half watt resistors myself here. As you can see, I'm writing them down that way. And something interesting, if you'll notice over here on the schematic, I always like to check back against the schematic too. If you'll notice, the feedback loop here in the original schematic shows a 22K ohm resistor here. I don't know whether maybe during the original build of this there were multiple versions of the schematic, and maybe this was an earlier version, and by the time they got around to building this amplifier they had decided that it was better to use a 15K ohm in the feedback loop, and they just haven't there's a later version of this that says 15K, or it could be that someone along the way wanted to change the amount of feedback provided in this amp and put a 15K ohm there to allow a little more feedback through. And so I'm not sure, but I know the unit was working with the 15K, so I'm probably gonna, if this was my amp and I was having to order parts, I would probably order a 15K and a 22K, and I would listen to the difference, and then I would leave in the one that I like the most. Okay. Fortunately for me, I've got a lot of resistor bins here already, so I'm not having to order these, but I'm kind of walking you through this as if you were going to have to order these. Okay, let's walk through the remainder of the resistors then. We've got this blue, gray, brown resistor here, which is a 680 ohm resistor. We also have blue, gray, black, which is a 68 ohm resistor, and we've got two of these 68 ohm resistors, right? Then let's see, we've got this yellow, violet, yellow resistor here, which the other day I called 400, in video 3 I called 470 ohm. In my head I was saying 470K, out my mouth came 470. If you ever make YouTube videos, you will realize what comes out of your mouth is not always what's in your head. And there are 3 of those, 1, 2, 3 here. And what else do we have? Oh yeah, brown, black, yellow, resistor here, 100K, and we've got 2 of those here at play. So I think that's it. That should document all the resistors. Let's get those written down. Alright, as you can see here now, we've got everything listed out. We've got our tubes listed, the 2 EL84s, 12AX7, and the 6V4. We've also got our capacitors mapped out here that we need to acquire for this. By the way, I have 2 of these mono blocks, so multiply everything on this list by 2, right, if I'm going to restore both of these units. Got our capacitors listed out, then we've got our resistors listed out here as well. So let's say you were doing this restoration and you don't have a tube tester, okay? These are EL84s, otherwise known in the US as 6BQ5 tubes. You can see here at the top of this one, it's kind of getting gray and faded around the top. The getter flash on this tube here is starting to fade away, and what that indicates to me is this tube's got a significant amount of life on it, or use on it, and it's starting to get a little gassy on the inside, ultimately eating up the getter plating here on the inside. And so I'd probably want to replace that tube, and since this is a push-pull amplifier, the way this amplifier works, and I'll walk you through that in a minute, I would recommend replacing both of these together with a matched pair so that you have equal transconductance, and since these are output tubes, you'd like to get equal current, plate current on these tubes as well, if you can get them matched that way. If not, you could probably play these for a while and they would sound okay, maybe just not optimal or whatnot. We've already replaced the 6V4 with a new one, and then we've got this 12AX7, and this is a RCA 12AX7 made here the 4th week of 1960. So I'm guessing this amp somewhere around that time frame, or it's possible this could have been replaced along the way. This happens to be what they would call a long gray plate ladder structure. And if you'll notice on the inside of it, I'll hold it here where you can see it, there are actually 2 plates. What there are here, this is a dual triode tube. There are 2 tubes inside of this one tube. Now, let's say you went and tested this tube and one side had more gain to it than the other side did, okay? Gain is typically measured in transconductance, otherwise known as GM, and the value you measure is micromhos. And let's say one of these had more gain than the other side, but both sides tested good. Well, in this scenario, you would be fine using a mismatched tube. There are other scenarios where that is not as good, and let me walk you through why that's okay in this tube scenario. So the 12AX7 here, right, there's 2 halves to it, and they show it here, one half of it and the other half of it. And what is happening here is this first half of the tube is a voltage gain stage. This is just a little Class A amplifier coming in here, signals getting amplified, coming out the plate, feeding over here into the second part of this tube. So it actually comes out of one side of the tube, feeds into the other part of the tube. So let's say this side was, you know, stronger than this side, or maybe a little bit weaker than this side. It really doesn't matter in this tube, because as long as you're getting enough voltage gain to feed the other, like I said, both sides are still testing within the good range, you're going to get enough voltage amplification to feed into this side. And this side here, if you'll notice, says phase inverter. This one said AF gain. AF stands for audio frequency amp. This is a phase inverter. And what you're doing here is you're taking the signal feeding into it and you're splitting it in half. So the positive peaks of the signal are going to feed over here, come out through a coupling cap, and go into this 6BQ5. The negative parts of the signal, those below 0, are going to come out, feed over here into this 6BQ5. So kind of think of it here like if you had a sine wave here, right? And the positive peaks are coming over here to this part of and the negative peaks here, they're coming down here to this tube, and you're actually splitting the signal gravitating around 0 volts in half. Part going to this tube, part going to this tube, then they get added back together over here. Well, since all this is happening in one half of the tube over here, then both of these sides should be equal. Means we're feeding equal into here, feeding out, you'll be just fine. But if this had been a scenario where you had a stereo amp, and the first stage here, instead of splitting this tube into audio frequency amp and phase inverter, what if you had split this as left channel AF and right channel AF, okay? And the tube would have been sitting here, and you would have used left channel here, or left channel here, right channel into the other half of this tube. And one side was stronger than the other. Guess what? All the way through the rest of your amplifier, whichever side was stronger here, the signal is going to be louder than the signal going through the other side of the amp. Similarly, if I had a second AX7 in it for phase inverter, and you were splitting it, this side is for left channel, and this side is for right channel. And let's say this amplifier was duplicated here. So in a stereo chassis, you see that a lot of times. And what would happen here is then one side's phase inverter might be slightly different than the other side's phase inverter, and then you may end up with differences in your left and right channel output. Since this is a mono amplifier, using half of this for AF, other half for phase inverter, it doesn't necessarily have to be a perfectly matched tube. You just want both sides to be good. All right, let's head over to the PC now at this point and select which components we're actually going to order for this. I likely have a lot of these in my bins in here, so don't have to order them, but I want to treat this like I was having to order these parts and walk you through some various options on that. All right, before we walk over there, I want to show you something about this can cap. I'm really going to give you 3 options on restoring these 3 capacitors right here, okay? If you'll notice, this can cap is physically mounted inside this unit really nice, and it's part of the original aesthetics of the amplifier, okay? So one option that you see done from time to time is people will leave that can cap in place, and they'll come in here and they'll basically cut all the leads loose from that can cap, but they will leave it physically mounted there, okay? And what they would then do is they would turn around and get 3 discrete capacitors and mount them somewhere inside the amplifier. And let me show you that. All right, so what you would do is cut all these wires loose. And if it were my amp and I was going to restore it that way, I would use like a little 5-lug terminal strip like this, okay? I've already got a mount right here that I could mount this terminal strip onto, right? So I could kind of come along and mount this onto that same little lug. I may have to drill the hole in this out just a little bit, right? But I could mount this onto that same little lug right there. And then that would give me, keep in mind that I could also run a little wire from this center one, because keep in mind this center lug on this is going to get grounded when you put it down here. But that's a transformer bolt. I don't know if I want to count on that as my ground. I'd probably run a wire from this lower little hole on this over and tie it in here to the chassis ground where other things are being grounded at, okay? And then I would just use 2 47 caps, and I could put one side here into this, and then I could kind of put the ground here on the other side like that, and do similar thing here with this one. There's my 2 47s. I could then mount my 22 over here, and I could run one of the leads, or run a little wire from down bottom over to that center, so I would have it grounded there as well. And then I would have my all mounted on a nice little terminal strip here. I would have the 3 capacitors inside of this. It's not the way I'm going to go with this amplifier, but it would look nice. Now, where I start to go, I see people take capacitors like this, and sometimes they'll put them in here in a little bundle like this, and they may kind of run wires over, and they'll like use hot glue to glue this down to the chassis, or they may put a bundle of them around like this, something like this. Let me turn it around here. They may make a bundle out of them, something like this, and put a zip tie around them and zip tie them down to something. I'm less of a fan of that. If I'm going to go the discrete component route here and not put a can cap back in it, I would probably use a terminal strip like this. Okay, so that's option 1. It is a valid option. These are 47 microfarad Nikon caps. They're really good caps, and it would work out well. So just so you know, this is probably a $10 route, okay, to get into doing this. I don't know. By the time you buy this little terminal strip, this may be a $12 route to go with replacing that can cap by doing it inside. Electrically, it is equivalent. It will be just fine. You would have no issues, okay? Option number 2, and it is probably for not the faint of heart, but I have seen people, and I have done it before myself, and I don't do it often unless a customer really wants it done and they're really willing to pay a lot to get it done. You take this can loose, you undo the little connections on the side here, unsolder it, untwist these tabs. These are called twist lock tabs, untwist them. You basically take the capacitor out, okay? Then you basically pull the guts out of the inside of it. And then you basically stuff those 3 capacitors I just showed you a minute ago down inside that can, and you use heat shrink tubing and things to keep the leads from touching each other, and then they come out the other side here. In my opinion, if you're going to go that route, I'd probably just go with mounting discrete components. And then there's option 3, which we're going to see here today in the video. I'm actually going to replace the can cap with a modern can cap. It is the most expensive route. Okay, so this route, least expensive, probably least aesthetically looking, depending on how you mount them. You know, using the terminal strip will really help make it look like a pro job, and I think it turns out to be kind of physically mounted much better. So least expensive. This is similar and expensive, most time consuming. You can spend a day doing 2 of these capacitors. And then the most expensive route would be to replace this can cap, as you'll see here in a minute. All right, the remainder of this video is likely to be long, and I could make it about a 10-hour video, but I don't think any of us want that. So hang with me here. We're going to go through picking out some components. So I'm not saying eBay is the best place to buy your stuff. I'm saying it is a good option in some cases, and I buy an awful lot of parts off of eBay, especially new stuff. This company here, Viva Tubes, they seem to have pretty aggressive pricing on tubes. And so I just searched, what I searched for was EL84 matched pair, right? And here's a pair of JJs. I've used those. They work fairly well. 25 bucks for a matched pair. By the way, you need 2 matched pairs if you're going to do 2 amps. They've got, let's see, here's a factory matched pair of Gold Lions. You got lots of options here. The Sotex, the Electroharmonics are not bad. Just scroll on down through. You could get you some new old stock, you know, EL84s, whatnot. You make your choice here on this one, on what you would want to do. These Tungsol reissues, I've used a pair of those. They worked out well. I actually believe they're making decent tubes these days, and for what you're using them for in this amplifier, I think any of these could be a good choice. So we'll just hypothetically say we order a set of these. All right, and then I've searched for 12AX7. Let's just assume we're needing to replace one of those. You might as well go ahead and get a matched pair. That way both amps have similar, they don't really cost that much more. If you're getting a single tube here, you can see 15 bucks. A matched pair of JJs. These are my favorite of newer 12AX7s, are the Sovtech 12AX7 LPS, which stands for long plate spiral. The actual filament in it is spiral, and you could get a matched pair here for $31. But I'm not making, this video is not about old tubes versus new tubes and which tubes you should pick. I'm just showing you've got lots of options here. And if the original tubes were good, hey, don't go down this path, don't replace them. But if I was doing it and buying some new tubes, I'd probably get these 12AX7 LPSs. I've used them in a lot of preamps, and they are very low noise and seem to be fairly good tubes. Alternatively, on the 6V4 tube, you know, there's a lot of older tubes out here, kind of like what I use. There's also solid state replacement plugins. I'm not a big fan myself. I could make a video all in and of itself on that. Doesn't look like anybody is making new replacement 6V6s, so, 6V4s. So it looks like you're in the $20+ range for one of these tubes. So pick what would work for you. And order one. All right, up next I searched for 40-40-20, and I'm looking for this capacitor. And if you'll notice, a lot of different options here. Now let's look at this for a second here, okay? Here is a 40-40-20-20, right, at 500 volts at $67, right? Here's a 40-40-20-20 at $58, 40-40-20, a pair of them at $108. Or down here is a 40-40-20-20 at $39. And guess what? Just because it has an extra section here doesn't mean you have to hook it up. So you can use the 40-40-20-20. The other thing that you can do when selecting multi-section can caps like this, let's say this had been an 80-40-20, right? Or an 80-20-20. You could add 2 sections together by paralleling them to get your 80 microfarad and then pick up your 20-20. Or if this had been an 80-40 capacitor, which is 2 sections, you could have put 2 of them in parallel to get 80 and the other 2 in parallel to get 40. So always think about being able to add these together simply by bridging together the 2 tabs at the top. This is not a bad deal. This CE manufacturing here at $39.95. And if you look at it, I've used many of these CE manufacturing. They're really good capacitors. The one thing I would tell you to check out is I would probably Google this model number right here. And it doesn't have it in here, but look for the height of this unit to make sure that it's not too tall to go inside of your unit. The other thing I like about this one is it is at 525 volts. Keep in mind, remember, you can always go higher on voltage rating. All that means is this unit could handle up to 525 volts, but you're only going to be putting, remember the previous one was a 450 volt cap. So what that means is you're going to be putting something less than 400 volts into it. And by using a 525 volt cap, it'll run even cooler. In other words, you're not stressing it as much because it's a higher rated capacitor. So think about those types of things when you're ordering these. But I think this is what I would go with. I was going to show you here on Antique Electronic Supply, otherwise known as tubesandmore.com. If you come down here and click on multi-section can type caps, you can scroll through here and find all sorts of values that you're looking for. Let's see. So this one, 40, 20, 20, you could strap those two together, right? And get 40, 40, 20. The problem is these don't have twist lock tabs, even though it would be cheaper, and you're going to have a hard time mounting this capacitor right here. Whereas if you come down, look, we found the 40, 40, 20, 20. And here's the downside of ordering from Antique Electronic Supply. You're going to have probably a minimum order, which you probably will have met to get, or you won't have met to get free shipping. And so you're going to have to pay shipping on this at $40.90. And over here, you're going to get it at $39.95. It's $1 difference. And, this company right here, New Old Sound, got a gazillion good feedback, and I bought a lot from them over time. Now, if this one had been listed by, Joe's Garage with 18 feedback, I would much rather pick an order from Tubes and More here. So split the difference however you want to go with that. But this is the can cap that we're looking at, and probably here inside of this, you can get your product measurements. It's 4 inches. That's the packaging in dimensions. Here you can get the actual item height, 3.6 inches. We're going to be fine in this scenario. So, sometimes I feel guilty. If somebody's going to give me the info here, I might just order this item from them. But, oops, I clicked on the wrong one there. Should have been clicking on this one. And look at this, 3 inches tall. So sometimes I might pay the $1 more because these people gave me the information I was looking for, and these people didn't. All these are personal preferences you can roll with. Okay, up next, I'm on there. I went down to their film capacitor section, and the orange drops are always good choices. The 716 series propylene. Tubes and More also offers some polyester. I'm not as big a fan of those. You could get by with using Mallory film capacitors here. A lot of people these days are using these Panasonic caps. They work out really well. So you could come down here and pick out your 22 microfarad, and you're going to pay 36 cents for it. These are really good capacitors, honestly, for what you're doing. You can get really exotic here and start spending crazy money. I'm a big fan of the Soling capacitors here as well. I like them a lot. You could find your 0.22 microfarad here. And instead of 35 cents, you're going to pay $2.25 for it, right? You can start getting into exotic capacitors of all types. You can get into... let's see here. I'm over on Parts Connections website. You can get into film capacitors here. Where you're starting to spend, like I'll give you an example. Let's find a 0.22 here in this scenario. This capacitor, a juniper capacitor, which is a copper foil capacitor, $69 for this capacitor. I'm just showing you the price swing, and I could make a several-hour video on this topic alone. You could always go over here on eBay and 0.22 microfarad capacitor, and you could probably find some orange drops, some Solines, some metallized film capacitors. Just make sure you're not using ceramic capacitors or any type of electrolytic for coupling capacitors. You could try to pick up some old Russian paper and oil. There are a lot of options. Honestly, for this one, I would probably, if I was wanting to spend a little bit of money, I'd probably go with the Solines. Otherwise, I would probably either go with these Mallories here or the 715 or 16 series polypropylene orange drops. All of them would work. And I like these too. I don't know what I'm going to use yet, but and this is where some people get into, wow, do components make a difference in the sound? It's a huge religious debate. Some will say yes, some will say I can't really tell. Blind listening test will lead you down all sorts of paths. but people believe in it, so thus the variety that's out here, and thus the price range difference that's out here. I think for just a general restoration, any of these types of capacitors right here would work quite well for you. So I can pick up all those. Okay, and I just searched for safety capacitor here, and I found some rated at X 440 volt to Y 250 volt. Anything above 120 volts, you're good here. This happens to be a 0.005, which will be just fine for what we're using here. Don't get too picky on these. They're just for kind of noise and safety purposes. You could order 2 of these at $1.39 each. Okay, you've kind of got a couple choices on your resistors, and this is what I would recommend for somebody that's just restoring a few pieces of gear over time. These Jonos resistor parts kits, you find them on Amazon. So you could get 1 watt value here, and it comes with 860 resistors. In other words, there's 86 different values in this pack, and there's 10 different sizes of each value, and they end up looking like this right here when you get them. So that, you get a pack of 100 ohms, and they're all in alphabetical order, and they're all in a nice little neat box to keep on your shelf. And these are metal film resistors. I use these little kits a lot, and I recommend them to a lot of people. That is one option. Next option would be on a website like Antique Electronic Supply here, and you can go through and find the value of resistor. And there again, a little bit of a religious debate. Do I want to go with carbon? Do I want to go with carbon film? Do I want to go with metal oxide, metal film, so on and so forth? Some people say there's big sound difference. Others say there's not. I believe they do make a difference, but probably not enough to warrant all the debate that takes place these days. So, make your choice. You can pick your values. You can add them to the cart and kind of get what you need here. You can find that larger value you needed, the 1 watt, select it and add it as well here. And then the third option would be to go back over here to a place like Parts Connection, where you're kind of getting into exotic parts. I'm a big fan of the Kwame resistors. I use them in a lot of the amps I build, and I'm also a big fan of these PRP resistors here. So you could come in here and find your half-watt PRPs, pick the value you need. They're usually anywhere 45 cents or so a piece. They're not very expensive. They're made here in the U.S., and they're extremely high-quality, good resistors. And for those that believe in resistor sound, I think they sound great. So you may say to me, Mark, you didn't really tell me a lot. You gave me too many options, and you didn't help me pick which capacitor to order or which exact resistor. Here's the reality. There are a lot of good options, okay? So a lot of those things I showed you, you won't go wrong. You can read on forums and kind of get people's opinions and whatnot. But they're all good options, so I'm not going to narrow you down to one. What I am going to do is tell you some things to avoid, okay? For any scenario where you have a capacitor in the signal path, in other words, the signal's going to flow through it in your amplifier in one way, shape, or form, stay away from Mylar capacitors. These little green ones, sometimes they're silver little capacitors, but stay away from Mylar film capacitors, okay? Next thing. Stay away from I gotta learn how to spell tantalum here. Stay away from little tantalum capacitors. Don't use them. They're notorious for being noisy, okay? Don't use those in your amplifier. All right, and while they do make 0.22 microfarad electrolytic capacitors, you do not want to use them. Do not use electrolytic capacitors in your signal path, okay, unless the original design used it there. They're fine for cathode bypass capacitors. They're fine for power supply capacitors, but they are not good for coupling capacitors. And really the only other thing that I'll leave you with is try not to use wirewound resistors in your circuit unless you don't have a choice due to the size, like in a cathode bypass scenario or whatnot. Because they can have inductance because they're wire wound, and it could affect your circuit. So a lot of the choices we've given you today are valid, and there's probably no right or wrong. Some may just sound a little different to your ears than others, and something you may not like, someone else may like. It all gets, we're in a very subjective space here. But when it comes to the amp actually working, a 100K carbon film resistor and a 100K metal film resistor work the same electrically. It's how they may color the sound of your amplifier is where it gets subjective. So all right, hopefully you learned a little something, even if just one thing out of today's video. Maybe it was worth watching. Up next, part 5, I'm going to get I had to order the 2 multi-section can caps. I don't keep those in stock. Everything else I had. When I get those in, we will restore these 2 units, get them fully functional, and let you listen to them. And then from there, we're going to move on to the next piece of tube gear in this tube gear restoration or troubleshooting series that we're working on. So stay tuned. We've got a lot more in this series, and I'm having a lot of fun with it, and hopefully you are too. And as I may have mentioned, some of this gear that I'm restoring, I'm going to put up for sale. So maybe you could, if you're interested, you could pick up some of it yourself. Thanks for watching, everybody.